Hello, welcome to this lecture video series on Module 4 of our Linux course. I'll be working through through chapters 1, 3, 4, and 6 of this book, Practical Linux Security. A lot of the lab exercises, some of which I've demoed already and some of which I will demo here shortly, come right out of this book. So if there's something you're not quite sure how to do, whether it's Nmap or disk encryption or rsync or whatnot, take a look at the book. Some of this is also covered in one of our other textbooks. For example, Linux Basics for Hackers. There's stuff about Nmap in here too, and probably some stuff about some of the other things we cover. In addition, of course, you know that we have what I've been calling the Yellow Book, accessible in Moodle through the good people at Red Shelf. This isn't exactly that book precisely. This is the next edition of that book. And it would help if I had it right side up. The Linux Plus Guide to Linux Certification by Jason Eckert. I've used version 4 of this book for a couple of years now. I really like version 5 as well. The thing about this book, it is very useful from a general Linux user, Linux systems administration perspective. It is not quite so useful once we start talking about security. They make brief mention of things like the security issues, containerization, etc., etc. We're going to go into a lot more depth using things, particularly things like Kali, also ParrotSec. The other thing that our course, other big way that our course differs from this course, is that this uses Fedora and Ubuntu. Our course focuses on the Debian side of the Linux family. Everything from Debian, of course, to Ubuntu, which we will cover in, I believe, chapter 4, or maybe even chapter 3. In any case, I've already done that lab demo, so you should go watch that. That's in the Module 4 VMs demonstration subseries. There are about 4 demos in that series. Ubuntu at the desktop, Ubuntu as the server, Kali, ParrotSec, which is another security-focused distro based on Debian. It has a little bit, some feature differences from Kali, for example. ParrotSec comes with OpenVAS right out of the box, whereas with Kali, you'd have to turn OpenVAS on and get it all set up. So I'm going to talk today about Chapter 1. Some of the concepts you'll explore in Chapter 1. Then we'll, of course, move on to 3, 4, and 6. So let's talk about Linux system security from a very general perspective. Now, there's some key things to keep in mind here. When we're talking about security, we're talking about accessibility. We're talking about who can install a software on the system, package management, that kind of thing. We're going to talk about data permissions and data access, and even recovery from failure. Because, well, you may think in terms of security, okay, I'm either detecting a digital intrusion or stopping one from happening. What happens if it has already happened? If you don't know how to get back to a working state, you don't have a full and complete tool set. That's why you'll see a lot of information about disaster recovery, business continuity, incident response, etc. on the Security Plus exam. Because we don't just study, as it were, now, if you were to think of us as the locksmiths of the information age, digital locksmiths. We don't just study how locks work. We don't just study how to make them better. We don't just study how to pick those locks, how the tumblers inside a safe work. We also study how to put the door back in the wall after someone has kicked it down. So we are also going to talk about backup recovery. Now, there are a couple of myths that you need to think about and then disabuse yourself of as we work on this. A long time ago, everyone thought Linux is virus-free. I don't need antivirus software on my Linux box because nobody's writing viruses for Linux anymore. Except they are. Because Linux is so prevalent in the server space, the chances are someone is going to try to figure out how to break into your Linux box. Well, not necessarily. I mean, the kind of Linux box that you've decided to build, whether it's Red Hat Enterprise or Ubuntu or Mint or Elementary at the desktop or Debian, whatever. Someone is thinking about, okay, how do I compromise that kind of Linux system? Maybe they're thinking about owning web servers, compromising MySQL databases, LAMP stacks, that kind of thing. Or maybe they're thinking about the end user. As Linux gets more popular, has always been popular in the server space. Though, as we've discussed, certain aspects of Linux are not quite as popular as they used to be. Used to be that Apache was the clear category leader for web servers. That is no longer true, both because folks have rolled their own or gone to other flavors of other products produced by the Apache project, say Tomcat. And Nginx is open source, but it's not Apache. And Microsoft IIS has gotten better and is now they're now the folks who are doing things like Outlook Web Services are probably doing all that on top of an IIS box. In any case, there is enough Linux out there in the world that people are thinking about how to break into it. So we cannot assume that Linux is virus free. You need an antivirus program on your Linux box, whether it's Fprot or ClamAV or something else. Just as certainly as you would not dare to deploy a Windows computer with no firewall, no antivirus. Don't do that with your Linux box either. So the other side of the thing, Linux is insecure because it's completely open. And this is actually another thing that you'll bump into in your Sec Plus course or your Sec Plus studies, which you should be studying for, by the way. The cryptographic algorithms which are open, which are well understood, are the ones which are secure. Even though everybody is looking at them. Everybody's looking at them and they're making them better and they're trying to figure out, okay, is this going to work? Whereas the ones which are closed, it's like, they think, okay, no one knows how this works, so it's secure. Not so. It is better to know how the algorithm works, and for everyone to know how the algorithms are. So the really, really smart people, say at our universities, our Tier 1 research schools, who spend all their time thinking about applied mathematics and computer science, if they're figuring it out, it's getting better. So we can't say Linux is secure because it's open source. We can't say Linux is insecure because it's open source. What we can say is Linux is more secure because more people are looking at it, trying to figure out how to make it better. And on the whole, I'd say there are more people trying to figure out how to fix it, how to improve it, than there are people trying to break it. Finally, Linux is only for experts. Everyone starts off as a GNUBie. When I say GNUBie, what I mean is GNUBIE, as in someone who is a noob or a newbie at GNU Linux. Everyone starts off that way. Everyone you know who is really, really good at Linux used to be really, really not good at Linux. I grew up with Windows. I took a class like this in college, and now I'm teaching it 20 years later. I use it on that computer over yonder. I've set up another computer dual boot. When my wife's computer is finally ready to give up the ghost as far as Windows 7 is concerned, I might run Linux there as well. Of course, this comes with a caveat. Don't load Linux on computers that aren't yours. If you think it's a good idea, but it's not your computer, you're going to have to sell that idea to the person who actually owns the computer. Don't ever, ever, ever just load Linux because you think it's a good idea. Because if it's not your stuff, it's not yours to. It's not your decision to make. So let's talk a little bit about security policy, and I'm going to have to. Looks like I'm going to have to go into another video on this one. So security policies. There's some overarching categories. User management. This is the same sort of thing you would have thought about in your server class. What users do you have on the system? What needs do they have? What groups do they need to be in, etc., etc., etc. Password. Password complexity issues, for example, as in how long does it need to be? How difficult does it need to be remembered? And now there's kind of a balance to be struck here. And this is more of a policy thing than a implementation thing. If you make your passwords too easy, people will break into them. If you make your passwords too hard, people will write them down, and that'll make it easy for someone else to break into it. So there's a happy medium there that you have to find. Configuration. A lot of what we do involves configuration. Say putting in the relevant applications and services, then configuring them correctly. Because if you just install SE Linux or AppArmor or whatnot and then don't set it up correctly, you really haven't gotten what you need. Then finally, monitoring. What are you doing to monitor the ongoing health of your system? Let's talk about a security checklist right quick. So, step one, installation. Did you install it? Do you have a plan for installing the system? And if you have a plan, did you follow that plan? Because really and truly, you should have a right, your business, your organization should have a right way to set up any given kind of computer, whether it's a desktop, a laptop, a tablet, a phone, a server, depending different kinds of servers. There should be a checklist and you run down it. If you are trying to figure out what good looks like for you, for your organization, that's when you improvise, when you play around. But once you figure out what good looks like, you do that over and over and over again. Boot and disk. Okay. Can you boot off something other than the hard drive? And you may need to lock those things down because, as you will discover, as I've said before, physical access is root access. If you can walk up to a device and plug in a USB and boot from it, whoever thought they owned that system didn't actually. Network and services. Where does it need to be on the network? What services does it need to provide? What implications does it have for its security configuration? What do you need to do to the firewall, etc.? Intrusion detection and denial of service. If you're providing servers, there should be a firewall between that server and the rest of the world. Also, how do you prevent denial of service attacks? How do you recover from them? How do you detect that they're happening and respond to it before that DOS attack melts your server? Auditing. This kind of goes back to monitoring on the previous slide. Are you monitoring, say, if you're logging literally everything, but looking at none of it, you haven't done your job. What you need to do is figure out what you need to log that, back that up, and we'll get back to backups in a minute, and then have a process for looking at what's going on in the system. A system which is not audited is not monitored, as surely as a system which is not logged cannot be audited or monitored. And then finally, availability. How do you make the system services that you want available on an ongoing basis? How do you survive minor outages? And how much availability do you need? There's a great deal of difference, for example, between 3 nines of uptime and 5 nines of uptime. I'm about out of time for this video. I'll talk about